Hey math kids, today we're going to talk about normals. And remember, a normal to a curve is a line which is perpendicular to a tangent at the point of contact. So if we have a curve that looks like this, we draw a tangent line. The normal line goes through that same point and is perpendicular or 90 degrees from the tangent. Okay, so it says find the equation of the normal of y equals 8 over square root of x at the point where x equals 4. So we want to find the point of contact first. So we're going to plug in a 4. So we get 8 over 2, which is 4. And so our point of contact is 4, 4. And then we're going to rewrite y as 8. So I'm rewriting this 8x to the negative 1/2. And so if we find the derivative of that, because we're trying to find the tangent slope first, we're going to bring down the negative 1/2. We still have the 8, and then we reduce this by 1. So that's our derivative. If we combine those, we end up with negative 4x to the negative 3/2. Okay. And we want to find the tangent slope at the point of contact. So I'm going to plug in 4 to this. So negative 4, 4 to the negative 3/2. We're going to get negative 4 over 4 to the negative 3/2, negative 4 over, not negative 3/2, sorry, just 3/2, and then 4 cubed under a square root. We break that up, that's 4 times 4 times 4. That pair can come out, and then this is a 2 and a 2, and so that can come out, so it's 4 times 2, so it's 8. So negative 4 over 8, and so we end up with negative 1/2. Now once again, this is the tangent slope that we just found. To find the normal slope, or the perpendicular slope, we need to do the opposite reciprocal. So we flip the fraction upside down and we get a 2, and then it was negative, so now it's positive. And so our perpendicular slope, or our gradient, or the slope of our normal line is going to be 2. Now, if we plug all this information, so this and this, into point slope form, which is y minus y1 equals mx minus x1, plug in our y value, plug in our slope, and that's the equation of our normal line. Okay, the next one, find the equation of the normal of y equals e to the x minus 2 at the point where x equals 3. So we're going to walk through it pretty much the same way as that last one. Plug in 3. So that's just e to the 1. So y is equal to e. So the point of contact is 3, e. Okay, we want to find the tangent slope first. So to do that, we find dy dx. So we do e to the x minus 2, and then we multiply that by the derivative of the inside, which is just a 1. So that actually is our derivative. And then we plug in our x value, so e to the 3 minus 2. It's going to be e to the 1, which is just e. And so our slope, once again, this is our tangent slope. Our tangent slope is just e. Now to find our perpendicular slope, we have to do opposite reciprocal. So opposite means we change the sign, so it goes from positive to negative. Reciprocal means we flip the fraction upside down, and so the perpendicular slope is that. And now if we plug it into point slope form, we're going to get y minus e is equal to negative 1 over e x minus 3. And if you want to leave it like that, that's fine. I'm going to turn it into y equals mx plus b, or slope-intercept form. And to do that, we distribute. So we get negative 1 over ex plus 3 over e, like that. And then we add e to both sides. And then we want to combine these somehow, and so to do that, we're going to do e over e, so it's going to be e squared over e, and if we add those together, we get negative 1 over ex plus 3 plus e squared over e. Alright, that's not much prettier. You can try to put it in standard form as well, or the way the book actually did it is they just added, they actually kept it like this, but just added e to this side and got rid of that. So it really doesn't matter. IB will accept all of them. If you have additional questions, please come to Math Lab. Until then, calculator.